Okay, kiddos, here's our video for this section. We're going to be talking about dividing radicals, and we're going to throw something else in there called rationalizing our denominators. And that's just a big, scary, fancy word for saying basically, I can't leave a square root or any other type of radical sign in my denominator. It's just improper for math. It's kind of like dividing by zero or not combining like terms or simplifying. It's a way of completely simplifying all of our answers. Okay, so we have a property that's going to drive what we're going to do today, and it's this guy right here. It says if I take the square root of a fraction, that's what we're doing. We're just doing fractions here. Don't be scared of fractions. They're just numbers, multiplying and dividing. Okay? If I take the square root of a fraction, I can actually say that's the same thing as the square root of your numerator divided by the square root of your denominator. Now, as you're taking notes in this, pay attention to what I'm saying as well. A lot of those things are important as we go. So, square root of a fraction is the square root of its parts. And the nice thing, this property can go in both directions. I can say that the square root of a fraction can be broken up into two pieces, or I can say the two pieces can be broken up, or can be combined, excuse me, into one fraction, and that will help us simplify things, as we'll see here shortly. Okay, as we go through and do this, okay, a couple things we want to look at. We always want to simplify the fraction first, if possible. You know, always, always, always. It'll make our life so much easier. Okay? If you can't, you don't. But if you can, simplify first. And then two, rationalize your denominator. And I will show you how we're going to do that. Oops, rationalize, excuse me. We're going to do that in a moment. Okay, so simplifying these things, we just looked at in our last problem of our warm-up, we simplified it, adding and subtracting these the radicals. We're going to simplify them the same way. And basically what I want you to treat this as almost two separate problems, especially with this property. Once you break them into two pieces, think about it as the top is its own problem and the bottom is its own problem, and then we can just put them back together in the end. It'll make it seem a lot less weird if we look about it that way. And the best way I think is just to dive in. So let's look at this problem. We have the square root of 48 divided by x to the fourth power. Now, as we go back and look at our pieces, I had the square root of a fraction. And we want to look to see if we can simplify the fraction first. So kind of pretend that the radical's not there for a second and just look at the stuff, the radicand. And look, can I simplify this piece at all? Is there anything about 48 and x to the fourth they have in common? Well, since this is a constant and this is a variable, they have nothing in common right now. So there's nothing I can do with this to simplify. So once we go through step one, I can't simplify it. I am then going to use this property to say, well, I can rewrite this as the square root of 48 over the square root of x. Okay. So what I did, I came in here and said, hey, I had the square root of a fraction, nothing simplifies, I'm going to break it up into two parts. That's what I did, break up into two pieces. Okay. Now I'm going to look at them separately. I'm going to simplify them that way. So we broke it up into two problems. And let's look at what happens here. Well, let's deal with one at a time, make our life a little easier, and then go from there. So let's start with 48. Let's make our little factor tree here. So 48 is 2 and 24. Oh, 2 is a prime number, so I'm going to circle it. 24 is 2 and 12. Oh, 2 is a prime, so I'm going to circle that as well. 12 is 2 and 6. Oh, there's another 2. And 6 is 2 and 3. And those guys are prime as well. All right, so if I take that again as a square root, I'm looking for doubles. Okay, forget about the x for a second, only look at the top. So if I look doubles, there's double 2's and another set of double 2's. So I take out a 2, another 2, and then what's left over is the square root of 3. So my top really simplifies to 4 square roots of 3. So as we're thinking about this, what I did as a quick review here, I had a fraction that I can't simplify. So I decided to turn it into two problems. That's this property up here. The square root of a fraction is equal to the square root of its parts. That's what I did. So the square root of the numerator I took, and it was a number, and as we've seen before, we broke that down to our factor tree, simplified it to this point, and then multiplied what I took out, and that got me a simplified top. Now I'm not done, but I still have the bottom part. In the bottom portion I need to simplify as well. We have to move on to our thinking with variables now. Okay? Variables, we look at the exponent. Remember, we're looking for the odd man out if it's there. Well, I have an even exponent. Okay? So even, all we have to do is really simple. Even means just cut it in half. Okay? So x to the fourth power, that comes straight out here. I have nothing left behind. I just have x and then squared. So then if I look at my problem in the end, how do I know when I'm done? Well, did I simplify the top all the way? Yes, I did. My bottom I simplified? Yes, I did. And I look, do I have a radical in the denominator? And if I look here, the answer is no. And then to finish things up, I look, can I simplify the outside stuff? 4 over x squared, do they have anything in common? No, they do not. So these guys are done. You can go no more than that. That's the best answer for this particular problem. That's it. Nothing else. Okay? Well, now what happens if I can simplify here a little bit? Well, let's look at that now. Okay, let's take, for example, the square root of 24x to the 6th power over the square root of 3x. Now, how this is a little different from what we just had above, here I started with a square root of the entire fraction, and I moved to two different square roots. Here, I have two different square roots. And if I look, and I kind of ask myself, think about it without the radicals there for a second. I have 24 over 3. That'll simplify. I also have x to the 6th over x. That will simplify. So let's make this into one fraction and see what happens. So I put it together, 24x to the 6th power over 3x. Well, this stuff all simplifies now. Look at 24 and 3. 24 and 3, I can divide them both by 3. I can take a 3 out of that, make it 1. I can take a 3 out of that, and make it 8. So if I have my fraction, so I have an 8 in the top now, because that's what 24 divided by 3 is. And then looking at our variable piece, remember again, when you divide, we subtract. So I have x to the 6th and x to the 1st power. And I look at it and say, well, where's the bigger one? The bigger one is in the top. So x goes there, and then 6 minus 1, you get 5. And I have the square root of that still. Okay? So I put them together to simplify. Now I simplify what I have left. So here I broke it up into two pieces and simplified each spot. This I put it as 1 and simplified that as a fraction. Now I'm going to break down the radical. So take 8. 8 is 2 and 4. 2 is my prime number. 4 is 2 and 2. Those are both prime as well. So again, if I look at doubles, I have double 2s, so take a single 2 out, leave room for your variable, and I have a 2 left over. Looking at my exponent, I have an odd exponent, so we leave one back. So I put an x here. That will take me down to x to the 4th. Okay, so take one back and cut in half. Okay, x to the 4th this becomes now. And I cut that in half, you'll get x squared. Again, look, I don't have a fraction, so I don't have to deal with rationalizing the denominator. That'll be the next example. And that's my final answer. So we went back, we combined them because they had stuff in common that I could simplify. I simplified the fraction, and then I simplified the radical. Nothing too crazy about it. Okay. Now let's look at something where we don't simplify and we actually have to rationalize our denominator. Okay. X to the 5th over x to the 18th. Once again, start with your fraction. And this is an example where we're actually going to rationalize the denominator. So let's be a good thing to put in there. So I have a fraction, I have a variable and number, nothing simplifies. So I'm going to go through and try to make this a little simpler. I'm going to break it into two pieces again. So square root of x to the fifth over the square root of 18. Okay. Now here's where we have a little difference. Okay. I have a square root of a number in my bottom. Now, 18 is not a perfect square. If I go back and look over at my first problem here, my square root of my number is my top, and I had nothing left over in the bottom. So 18 is not a perfect square, so I need to simplify that first, just to see kind of what happens here. So I'm gonna break down 18 into a couple different pieces here. This is gonna give me 2 and 9. 2 is my prime, and 9 will give me my 3 and a 3. Okay, so those are my primes as well. I have a pair of 3's, so I take out the 3, and I'm left with the square root of 2. And this is over. Let's simplify the top. Well, it's odd, so leave one back. Becomes 4. Cut it in half. You get x squared. Okay, so I got to this point, and now here's the problem. The problem is the square root of 2. I can't end up with a radical in my denominator. It's a big no-no in math. It's just one of those things. They don't like it. It doesn't make sense to us. It doesn't work. Okay, it's like having like terms you didn't have combined. You have to simplify things to make it work for us. All right, and now notice there's no addition or subtraction here, and there's nothing there to kind of really throw a wrench into things, but this is just one thing that we have to take care of. So here's the easy way to look at it. I need to multiply by something that will kind of get rid of my my radical. All right. Now, if you took your calculator or just thought about what we did before, if I took the square root of 3, and this is a little side note, multiplied by the square root of 3. Remember, when you multiply radicals, you keep the radical and multiply the part underneath. So that'd give me 9. Well, 9 is a perfect square. If I took the square root of 9, I would get 3. Look, no more radical. Okay? So that's the idea we're going to use here. If I can do that, that'll work out great. Now, the concept in math is you can do anything you want to a problem as long as you don't change values of things, meaning you don't just all of a sudden throw a +5 in somewhere. You have to always balance stuff out. So what I'm going to do is look at the radical part. I have the square root of 2. Well, I know from my little side example, if I multiply a square root by itself, look what happened. I had 3, and my answer was 3. So if I come over here and multiply the bottom by the square root of 2, the square root of 2 times the square root of 2 is going to cancel out and give me 2, just like here. Square root of 3 times the square root of 3 was 3. So I'm going to take that same understanding, but now I need to balance it out. Since I did that in the bottom, I need to also do it in the top. And I get 2. All right, well, let's take that and see what happens. I had an x squared in the top. Remember, multiply your radicands together. So I have square root. 2 times x is 2x. In the bottom, I have a 3 times the square root of 4. But as we saw over here, that gave me a perfect square. Okay, that's wonderful. So the square root of 4 is 2. And if I do the multiplication, 3 times 2, you get 6. So if I look, do I have a radical in my denominator? Nope. Do I have anything I can simplify up here? 2's prime, x is prime? Nope, I'm good. Now, here's a mistake you're going to think about making. You see 2 over 6, and you're going to want to reduce it. You can't reduce because of the radical. Okay? This radical right here is like parentheses. It keeps things kind of tucked in its own. You can't reduce that at all. So 2 over 6, no, no, no. You can't do 1 over 3. And because the radical kind of keeps it in jail there. Okay, so that's rationalizing the denominator when there's no addition or subtraction involved. Just remember, simplify your denominator first, and then all we did was multiply it by whatever the radical part is here. That's what we did. We multiplied by your matching radical. Oops, I spelled matching wrong. Okay, I did square root of 2 and square root of 2. That gave me what I multiplied. Remember, top and bottom by it. So that does that for us. Now, the complicated part about all this. That's a little weird, but this is a little stranger. Notice we now have addition and subtraction. So this is going to be rationalizing when there's addition and subtraction. All right, so when addition and subtraction are present, we have to kind of go another route here. So with this, what we're going to do is we're going to use something called a conjugate. Okay, we're going to use a conjugate. What that is if I have something plus the square root of something else. Okay, its conjugate is the same thing, just with a minus in the middle. Okay, so that's not a weird thing. It's just how we multiply things together becomes a little tricky. But we've done this before with square roots and whatnot. We just have to keep them in mind when we multiply. So the conjugate is this a minus. So just change the sign in the middle of it. That will help us get there. Okay, so let's deal with that really quick. So if I look, I have subtraction. Remember, subtraction screws everything up. I can't simplify here. Okay, when you have multiplication, you can just simplify right off the bat. But here, I cannot because I have addition or subtraction. You need to write that in big bold notes somewhere in your notes. I can't simplify right away with addition or subtraction. I have to use my conjugate to get there. So let's just right off the bat start with that. Okay, I have 4 minus the square root of 2, so my conjugate would be 4 plus the square root of 2. And again, I did it in the bottom, so I need to do it in the top. Now, here's the difficult part of it, is multiplying the bottom piece together. Okay, we're going to go through and treat it like two binomials. And you guys have done this before where you just take piece by piece. So I'm going to do the double distribution here. So I have 4 times 4 plus the square root of 2, and then a minus 2 times 4 plus the square root of 2. Okay, so let's tackle this. Again, don't be scared of all this stuff. It's not too crazy. It just looks weird. So we distribute the 4's in. So 4 times 4 is 16. Okay, and then plus, well, 4 times the square root of 2 is just 4 times the square root of 2. I can't do 4 times 2 because this guy doesn't have a radical. So there's the first one. And then I have minus over here. The square root of 2 times 4 is, again, 4 square root of 2. Then we write the number before the radical. And then minus, because a negative times a positive is a negative, the square root of 4. Because remember, when you multiply a radical times a radical, you can multiply the radicands. Now look at what happens when you do this. Okay, the square root of 4, that becomes 2. Okay, so let's go through and look for like terms. I have a constant and another constant. I have 16 minus 2. That's 14. But look what happens here. I have a plus 4 square roots of 2 and a minus 4 square roots of 2. Well, holy cow, look what happens. Plus, minus, they cancel out. They're gone, and 14 is my answer. No more radical. That's what I wanted. Remember, that's the idea of rationalizing your denominator. I don't want the radical anymore. It's gone. Nothing good comes from it for me. So I have 14 in my denominator now. That guy came up here to my denominator. Now up top, it's nice because then I can just do distribution. So 6 times 4, that's 24, plus, again, 6 times the square root of 2 is just 6 square root of 2. I have that. I have my answer almost done. The last thing I have to do is simplify this fraction. What I'm going to do is break it up into two pieces. I'm going to do 24. I'm sorry, I'm not going to break it up into two pieces. I'm going to look and see that they all have a common factor of 2 because they're all even. So I'm going to divide everything by 2. Not the radical, the numbers. So that gives me a 12 plus 3 square root of 2. Notice the 2 didn't change. 14 divided by 2 is 7. So I divided by 2, divided by 2, divided by 2. If you couldn't divide them all by 2, I'd leave them as one chunk. But that is my final answer there. So deep breath, stop freaking out, go back and watch it again even if you need to, because then you can kind of get a feel for what it is. You can rewind it and stop and go back, pause. If you need to, you can email me a question. I'll have my computer. I can email you back. But this is that idea. This is as funky as it's going to get with this, folks. This is the nastiness. We'll call this one the big nasty as we go through. So dealing with this is what we have. Do your best. Try your hardest. Don't give up, folks. We got to push through. We got 2 weeks left, and we're going to be A-okay on this together. So good luck. I'll see you tomorrow. Hope everything goes well today. Be great, as you always are.